Page 2, measures of variation. So this is how to compute the standard deviation. And really, up until the next page, so we're going to actually be working on finding the variance. So this whole part right here is all dealing with variance. It's really not until the next page that we do the final step that takes us into finding the standard deviation. So this whole side is variance, and it's only one more small step to get to the standard deviation. I just don't want you to be confused. So step 1 is to find the deviation or difference. I'm going to put difference so you know those are some synonyms. Difference from the mean, deviation, difference. So to plug in our values, we're going to use our two data sets, and we're going to make the comparison using standard deviation now instead of range. So I'm going to write these in here for us so we don't have to keep flipping back and forth. It's the heights for team 1 were 72 inches, 73. As long as we're doing calculations, you can leave the units of measure off and then put them back on at the very end. 72, 73, 76, 76, and 78. So those are our data points. Right now, one at a time. Team 1, yep. And then we're going to find the deviation or the difference. So we're going to take each point, and then we're going to subtract the mean, which we calculated. What did we calculate it to be? 75? 75? So 72 minus 75, that's negative 3. 73 minus 75, that's going to be what? Yep, negative 2. 76 minus 75, just 1. And 78 minus 75, that's 3. Now one thought would be, if I'm just trying to figure out this standard deviation, would be to add all these together and divide by how many there are. We're talking about relating numbers to the mean. So try adding all these up, and what do you get? 0. Right, we get 0. Therefore, we blank the deviations. We're going to square the deviations. Then they'll all end up positive, and then we'll actually end up with a number versus just 0 divided by anything is 0, and we obviously have some variation in the data, so we want something that gives us a little more information. So we're going to square the deviation. So we're going to take the x minus the x bar, which we've already calculated, and square that. So that's what you want to put as the title of this third column. So we're going to take negative 3, and we're going to square it and get 9. Take negative 2 and square it, and we get 4. Take 1 squared, and we get 1. 1 squared is 1, 3 squared is 9. So now we're going to take an average. Now we'll take an average of the squared deviations. Now here's the funny part about this. We're going to divide by n minus 1, which in our case is 5 minus 1, or 4. We're going to divide everything by 4. And it's kind of a weird concept to understand, and I'll explain it to you here. You'll have some reference on why we're dividing by n minus 1. So one of the main uses of sample variance is to estimate the population variance. Right? We call that inferential statistics, where we take a sample, we find out some information about it, and we project that information on the population. And when we just divide by n, which we tend to do, that's how we find average. If we just divide it by n, it tends to underestimate the population variance. Right, so when we're finding a sample variance, we will divide by n minus 1 so that it can give us a more accurate or give us the correct value for the population variance. So S squared, this is the symbol used for sample variance. Right? We use X bar to represent sample mean. We use S squared to represent sample variance. And we're going to calculate that by adding up all of our, and I'm going to write it out here, we're going to calculate the sum of all of our X minus X bar squareds and divide by n minus 1. So it's not a whole lot different than the formula that we used to find the mean, right? I told you this was our baseline for becoming familiar with some new symbols. Right? Now we're just, instead of just adding up the x values, we're adding up the squareds. So we're going to take and we're going to do, okay, add up 9 and 4 and 1 and 1 and 9. So it's a fancy way of writing something. It's really not that fancy. We're just adding up all of the squared differences, dividing by n minus 1. When you add all these up, we get 24. We're going to divide by 4, and we get a value of s squared equals 6. So my sample variance for team 1 is 6. It's really good. Last step then, we have one more step to take this to find the standard deviation. Right now we're in square units. How would we go backwards and just be at units? Square root it, yes. So the only last step that I have to do to go from variance to standard deviation is to take the square root. So for team 1, we're going to do s equals the square root of s squared, or the square root, for our example, the square root of 6. I'm going to use my approximation symbol, which is an equal sign made squiggly, because I know that it's not a perfect square. Therefore, I have to round my decimal, since it will be an irrational number. 2.45? Can I get a second 2.45? 2.45 is how we could round that to the nearest hundredth. So we have 2.45 as our standard deviation for the sample. Now we'll walk through an example of how to find the sample standard deviation for team 2.